Hey everybody, I've had a few requests to go over some of the tools I use in my build videos, and I think it'll help with the ones I'm already publishing as well as some I have upcoming. So we'll go through some of the basics and how to use a few of the tools. I may cover some more in depth later. Certainly get yourself a basic drill bit set. That's a no-brainer. One of the ones I do recommend, especially for the power box builds, are some of these stepper drill bits. These are fantastic. You will cut a perfectly round hole, very clean, but be careful. You don't want to go too deep. You can never make a hole smaller, but you can make them larger. So you can see they come in various sizes. Make sure you use the one that's the right size so that you don't overstep your bounds, right? You don't want to end up with something too big that doesn't fit the component you're trying to seat. But these are amazing to be able to have just a simple set that'll get you to any size hole you want. So step bits are super useful. I'll put links to examples of all of this in the show notes, so you'll have that there as well. A few other things. Good pair of cutters. These cutters here, you can use other types of blades. I love these here. They help me cut through the power box supports when I'm trying to run wires and do some other things. They cut very clean through the plastic. They're really easy to use. They don't take a lot of strength or pressure to make the cut, and I can remove the plastic that I need to very, very easily. So those are very handy as well. So one of the things I do in a lot of the projects I have is I try to get back to 12 volt power. Almost everything on my telescope rig is 12 volt power DC, and of course everything coming out of your outlet in the US is 110 AC. So we end up with a lot of these power bricks that are 110 plug into the wall, the big heavy brick that just converts it to 12 volt DC. So what I like to do is remove all of those bricks, because if I can remove the AC side of the equation and just go to simple 12 volt DC out of all of my components, that allows me to connect everything together 12 volt DC and then run into a 12 volt DC power supply. So I have a single 12 volt DC power supply here. Here's just a simple example. So I put this near my mount. I run this to a 110 outlet. These are also 220, but I run this to my 110 outlet here in the US. And then I have power pole, Johnson power pole connectors. I can actually plug in here and then run all my equipment 12 volt DC without any other power bricks. So this replaces all of my power bricks. The other thing that this does for me is this allows me to seamlessly go from this power supply that's pure 12 volt DC out this side to a 12 volt battery in the field. So now once I've converted everything, I don't have a lot of power converters. I just have a 12 volt DC power supply battery, and I can just unplug from this one when I leave the house and plug into that battery or my battery pack, which we're going to build out here soon. So just again, something to think about. If those power bricks are in your way, it's something you can do as well. So a couple things. How do I do that? Well, if you do electrical work and you don't have one of these, you need to be looking into it. So this is a very simple wire stripper. They make better ones, but this will do the job. You can pick this up at Lowe's. I probably find it online at Amazon for everybody, and just put a link out there. But what this will allow you to do is strip the sheath and the wires themselves. So here's an example. I cut a power brick, removed the power brick itself, and of course this is a short end. Usually I would cut this to length much longer, but what I've got here is the part that goes in the camera or the telescope or whatever the other 12 volt DC device is. The brick is now missing. So what do I do, right? So I've cut this off, and of course again I'd usually leave this a little bit longer. I want to strip this, so I go ahead, and if you can see that, I insert that. I'm going to give myself a little bit of room to spare here. So let's go ahead and do that. So I got that in there, and I'm going to just grab it and pull. And what you'll see here is it pulled the sheath off pretty cleanly. So I've got the sheath removed pretty easily, and it exposed a red and black wire that's pretty easy. So now what I'm going to do, I'm going to go ahead and take some more of this off just to make it easy for everybody to see. So again, I've removed more of the sheath with my strippers, and I've got red and black wire here, pretty easy to use. So now if I put these red and black wires together, the beauty of a good wire stripper is that I can actually insert them both at the same time, right? So I've got them both here side by side. Go ahead and pinch down, pull, And you'll notice here, what do we got, right? I've got both of them stripped simultaneously. Now I've got bare copper. So I'm gonna go ahead and spin this over. So this is an easier one. If you're doing this on your own, you still probably don't want to trust it if you don't know really how this is put together. This is set as red and black wire, so red is typically positive, black is negative. Now I'll put a picture on the screen, but something that's important to note is most of your power supplies, and you gotta verify this for each power supply, but most of your power supplies are going to be center positive. So on the screen right now you should see an image of what you're looking for on your power supply, but if this is center positive, I want to make sure then I know what wire corresponds to the center pin, the positive. To do that, we are very typically going to use a multimeter. You can get an inexpensive multimeter. They're very handy, especially if you have projects like this. I'm going to go ahead and move this over to our toner capability. So you'll notice here we've got a audio sound symbol here. So I've switched it over to that. I'll try to point this so you can actually try to see this here. So hopefully you can read that. And what I'm going to do is in this example, even though I have a red and a black connector here, I don't really care what's positive and negative from the toner's perspective. I'm just trying to get a complete circuit. So if I put these together, I get a sound, right? So what I'm looking for is to try to determine which one of these wires gives me the sound when I need it. So center positive, I take this and I'm going to insert this into the middle. So you can see it's just sitting in the middle, pretty straightforward. So I've got the connector in the middle. So now I take the other end and I hold it. So if I hold it to black, I get nothing, right? That's what I expected. Center positive should be red. If I hold it to the red wire, notice I get a tone. Now, if I want to check the negative side, I have to hold it to the outside of the barrel connector here. If I hold it to red, I get nothing. If I hold it to black, I get a tone. So what have I learned? This is center positive. The middle is positive as per the power supply and what it's expecting on my device, and red corresponds to the center. All right, so let's put this aside. Now we're going to talk about Johnson power pole connectors, because that's what I love to use. And I'll put some pictures on the screen to hopefully simplify what this looks like. It's going to be hard to see. But with power pole connectors, you've got these plastic connectors, both red and black. So hopefully this will come into focus here, but you got red and black, you can see those, right? And the way this works is you can actually put these together and they will connect like so. And what we're looking here to do is to make sure that we've got them set up so that they will plug in to our power supply correctly. And again, I have these connectors on my power supply, and I also have an adapter, a power brick here. These are very inexpensive. It's a great way to join everything together, pretty straightforward. So what I want to do is put these together. So I've got these together here, and you can see they're connected, and I've got them set up so I've got red on the right, black on the left, looking down from the top. Now that's the outside, but what's important now on the power pole connectors is these pieces in the middle. So these are the metal connectors I need to put on here. So what I'm going to do is I'm going to do the red one first, and basically all you do is get it on there. And I prefer the power pole connector crimper. You can do this with other types of crimpers, but I do prefer the appropriate crimping tool. So you're going to get it in there, and then once it's in, we can simply crimp it down. And you can see I've got the red end crimped. So we've got the red end crimped. So now we're going to do the black end. And again, I would do this for each of my power supplies so that I can remove the brick. Even if there is no supply, as long as you know it's 12 volt DC, if it's native 12 volt DC or what have you, you can actually do that as well. So if you've got a cigarette lighter adapter that's native 12 volt DC all the way through, there is no brick, but those cigarette lighter adapter connections, I hate them. They come loose. They never stay tight in the socket. So I tend to remove those as well. So I just cut the end off that. I don't need that piece, and I put power pole connectors on there. So what do I have here? I've got both on there. So I've got my red and black, and I know my red's positive. So I'm going to go ahead and insert this. Now, when you insert these, you should hear a click. Some of these smaller wires are a little bit more challenging to get in there. So the power pole people come up with this insertion removal tool. You can use a small screwdriver, but I do find this to be pretty handy. It actually works pretty well. Listen for it. And of course, all right, so you heard the click there. So now I'm going to go to the black side, put that one in, and we're listening for a click. Hear it, click. So now I've got my wire connected, and I've got a power pole connector on there. So, you know, usually I wouldn't leave as much slack. I would make that a little bit cleaner, not quite as much slack, but that's okay. I mean, we can make this work. So we'll take that. So now what do we have? Well, now I just have to plug this in. So as an example, I can actually take this and just put this into this brick here. And again, if I had other devices, I could join them up all up here. I can run one of these wires directly back to my power supply. So just to see what I'm talking about here, again, if I come back to my continuity test, I can go center positive. I'll just put one of these connections in the center pin. So that's center positive. So I would expect is any one of these reds, right? Any one of these reds connectors to make the tone. And I do. Every one of these reds makes the tone. The black does not. Now if I leave this in the black, pull it out of the center, all I have to do is touch the outside and I get a tone. So again, so it's as simple as that. So this is just wiring, it's just connectivity. You still need to put some 12 volt on this, but again, if I connected a wire from here, Johnson power pole connectors on one side to the other to my power supply, this whole thing would be energized 12 volt DC. And again, this is something you can easily mount a piece of Velcro or tie it down to your telescope, right? Or you can simply just join everything together, right? So reds to reds, blacks to blacks, run them all back to a single point of entry. Now, they do also make these power meters. So there's a source side and a load side. You see they come with no connectivity on them whatsoever, so you just have to wire these up. Again, what do? I put power pole connectors on them to make them handy. So if I actually take this and on the source side, I can plug this in to my power supply, and this will immediately power up. And I can see I'm drawing 0 amps here. So we'll leave that there for a second. I can see I'm at 13.92 volts. So why would I use something like this? This gets really handy when I want to know what my gear is pulling, so that I can use this, again, plugged into an AC power source here when I'm at the house, but it's really handy to know what kind of draw I have for when I go into the field so I can size my battery appropriately. So again, super handy. Now, I talked about removing your bricks. If you're not comfortable removing these ends from the power bricks yet and you want to start a different way, they do sell these multi-packs of ends. So it's basically, you know, a multi-pack of barrel connectors with the red and black ends exposed. Now, the problem I have with these is they tend not to be, in many cases, long enough for my purposes, depending on how I'm running them, from maybe a camera or filter wheel to where they need to go. Now, I can crimp these together with some other cabling, but you know, again, what you'll find typically is this can work great in certain cases, or maybe when you're practicing, but using the full length cables, the 6-foot, 5-foot cables you get with your gear is going to be a lot cleaner. So again, you have multiple options. So let's move some of this stuff out of the way. Now, one other thing I want to go through while we've got the multimeter out, let's move some of this out of the way, is I want to go through switches. So again, I'm going to go back to toning. Now, we use multiple types of switches in our tests in our boxes, and this is a simple on-off. So 0 is off, so 0 is off, and 1 is on. So pretty straightforward switch here, right? Nothing too fancy. Now, this particular switch, if you can see it there, has 3 prongs, and that's because this lights up when it's on. So really what ends up happening with this type of single pole switch is that you take the positive, and you typically just need to go positive in from the battery or power supply to one side, and then when the switch is on, power will go out the other. This particular switch, because it's powered itself, has a negative connection. Now we don't need that for our purpose here to test, but what I want to show you is that when we are in the off position, if I hold from a continuity perspective onto one of the positives and the other, I get nothing. However, when I throw the switch, pretty straightforward, I hold it, go to the other one, we have power. So it's a good way to say, well, I'm about to wire this up, but I don't know what to connect where. Use your multimeter, turn it on, see where the power flows through. Now you know where your positive connections go, one side or the other. A little bit more confusing is this particular switch here. This is a dual throw switch, and you'll notice instead of just the 2 or 3 connectors we would expect, this one has 6. And the way this one works is that in the middle, this is the off position. This is where your battery would go, positive and negative. Now this side is if I throw the switch into one of the on positions, this positive and negative will start to take the power from the battery. If I throw it in the other direction, the other side, positive and negative, will take the power, right? So this is a dual position. Now I like to use this type of switch in some of my projects, especially the battery projects, because what I like to do is have a sealed box. So what this allows me to do is in the off position, I have the battery connected, not flowing anywhere. If I throw it in one direction, power is only going out that side. Both positive and negative are now connected to the battery, and that could be my all-sky camera or something else completely powered. Or if I throw it in the other direction, now the all-sky camera and those pieces of equipment are not powered, but the other side is flowing through to the battery. And this could be connected to a charging port that's outside the box. So this gives me the flexibility to have maybe a fan on one side for when I'm charging and the charging port available. However, I throw it in the other direction, I've got a fan running to air out the box and any fumes that may be coming off the battery, as well as powering my gear. But only one or the other can be used at any given point in time, and then certainly if it's off, then nothing's connected to the battery. So this, while a little bit more expensive than these other switches, there are places where you do want to use something like this. So just from a toning perspective, again, we've got basically, we're going to have our positives all on one side and our negatives on the other. So if I were to connect this lead to the middle one here where my battery maybe positive would be, right now it's off, I have no connectivity. If I throw it in one direction, again, I've got the battery lead there, I can test it. Oh, not this side, it's on that side. So now I know when I throw the switch in this direction, it actually is connecting these leads over here. If I throw the switch in this direction, it should be powering the other leads. So again, it's just, multimeter can be extremely handy so that you can see what you actually need to connect when you're moving forward. All right, one last piece I want to cover for this video is some basic other crimp style components. These are called terminal sets. So terminal sets can be pretty handy. Lots of different style connectors. You can pick these up just about anywhere. But what we actually have here is we have multiple things. We have a ring style connector, angle style connectors maybe for batteries. We've got some connectors here that are barrel connectors that just are, you know, they're see-through here. We can actually connect a wire on each end and crimp them down to join them. We've paddle head connectors, and we'll use various things in our project. So let me just show you how we can actually join together 2 wires. So let me just cut a quick piece of wire here. Cut a quick piece of wire. I'm actually going to peel them apart. Well, first let me strip the ends, make it easy. So I'll strip the end, one end stripped. Strip the other end real fast. Alright, so now I've got this wire, and I'll just pull it apart. I don't care about red and black for the point of this demonstration. Let me just twist them to make them nice and nice and clean. So I've got 2 wires, and I've got this basic connector here that I'm going to use to connect them. So what I'm going to do is I'm actually going to go ahead and just insert this 1 wire, and what you'll see in these when you get them, it's a plastic sheath on the outside, but there is a piece of metal in the middle. So I'm putting this down into the metal on this end, and then I'm going to take these crimpers, very easy to use, they're basic, this is a very cheap set, and I want to land on where the metal is touching inside, and I'm going to squeeze it down, and what that's going to do, squeeze it nice and tight, and that's going to crimp this. You can see that very, very tight. It's going to crimp it down so that it cannot come out. And what I'm going to do now is I'm going to go ahead to the other side, and I'm just going to put this in there. So if you haven't done any crimping of wires, it's just nothing you should be afraid of. So we're going to go ahead and put this on here. I'm going to crimp the other end nice and tight. Now again, what do I have? I have basically the metal barrel in the middle has been pinched with the wires inside. This will not come apart. It's nice and tight. And again, from a continuity test perspective, if we want to hear it, I just have to touch one end of this wire. The wire flows through our crimp connection and out the other, and if I touch the other end, we should have a signal, right? So again, that's where my 12 volt would go through. So just so you can be familiar with all of this, right? I mean, there's nothing to be afraid of here except for power itself. So you certainly have to be careful when you're dealing with power. If you're not comfortable with power, don't take on any of these projects. Don't touch anything when it's live. Make sure you understand the power. But it is something that most people are capable of handling. Last piece I want to show you from a wiring perspective, and you can see I've got Johnson power pole connectors on this, of course, as well. This is a single inline fuse connector. So if I pop this open here, there'll be a single fuse. This is a typical like automobile fuse, ATO, ATC blade fuse. So you can get these very cheap as well. And notice I've joined it with a single strand black wire that I've twisted around there. That's my ground. So now if I plug this in the path between my power supply or my battery and my equipment, I do have a fuse here to help if I ever have any issues that a fuse could help with, any sort of power short. Typically your fuse is going to go as close as possible to the power source. So you want to put this on the positive lead as close as possible to the power source. So usually I would plug this in, to my power supply, and then into either the cable that goes on that joins everything together, or as close to the battery as possible, and you'll see how we use that as well. So I hope that helps. There'll be other videos coming up, but I just wanted to make sure I made this basic video about some of the tools, how I use them, so that we don't have to go through them over and over in some of the build videos. Hope this helps. If you have any questions, certainly ask in the comments. Hopefully you enjoyed this video and it cleared some things up. If not, certainly ask questions, but thanks for being here.